Okay, Assalamualaikum. My name is Adrian Petrus. My metric number is 07DKM21F2039. Now I will talk about chapter 1, which is steam power plant. Okay, now I will talk about the fire tube boiler, which is the locomotive boiler. The locomotive boiler has a rich historical background, closely tied to the development of steam locomotive and railway transportation. Steam power emerged as a revolutionary technology, offering a more efficient and powerful alternative to traditional sources of energy, such as water and also wind. The application of steam power to transportation began with the development of steam-powered locomotive. Okay, now I will talk about the part of system in the locomotive boiler that is essential to make sure the locomotive boiler is working perfectly just fine. The first one is firebox, combustion chamber, grate, boiler shell, tubes, the smoke box, the smokestack, steam dome, the safety valve, water level indicator, and also pressure gauge. Okay, now I will explain the working principle for this boiler. The first one is steam generation. Locomotive boiler generates steam by heating water inside the firebox. The next one is heat transfer. The heat produced during the combustion process is transferred to the water surrounding the firebox. The next one is pressure control. The pressure inside the boiler is precisely controlled to ensure safe and efficient operation. Okay, the next one is steam distribution. Once enough steam pressure has been achieved, it is routed through pipes to the locomotive cylinder. The next one is water level management. It is critical to maintain the correct water level inside the boiler. The next one is combustion control. The combustion of fuel within the firebox must be carefully managed to maximize efficiency and reduce emissions. The next one is regular maintenance. In order to operate safely and efficiently, locomotive boiler must be inspected, maintained, and cleaned on a regular basis. The last one is safety precaution. Safety precautions are essential when operating a locomotive boiler. Proper training, adherence to safety regulation, and constant monitoring of pressure and temperature are critical for avoiding accident and ensuring the safety of crew member and passenger. Thank you. Now I will talk about the advantages of locomotive boiler. The first one is compact design. The second one is quick steam generation. The tiny size of locomotive boiler makes them extremely portable. The next one is adaptability, ease of maintenance, robust construction, and also cost effectiveness. Okay, the next one is the disadvantages of locomotive boiler. The first one is limited steam capacity, space constraints, efficiency, safety concern, environmental impact, fuel handling, and also the last one is maintenance requirement. Thank you.
My name is Muhammad Azizwan, matrix number 07DKM21F2017. So now I will go through about water tube boiler, which is Benson boiler. The Benson boiler represents a significant advancement in steam boiler technology, particularly in the realm of supercritical steam generation. The background of the Benson boiler can be understood in the context of the evolving need for more efficient and reliable power generation methods. Supercritical steam refers to steam that is heated to a temperature and pressure above its critical point, where the distinct liquid and gas phases no longer exist. So now let me introduce about part or system that been used in Benson boiler. So there are totally 9 parts that been used in this system, which is water walls, furnace or combustion chamber, feed water system, the boiler drum, the steam separator, the superheater, reheater, safety valve, and burners. So now let me explain about work principle in Benson boiler. First, high pressure steam generation. The Benson boiler runs at extremely high pressure and temperature, generally above water critical point. Second, water circulation is the process of pumping high pressure water into boiler tubes. As it flows through the tube, it collects heat from the combustion process and converts to supercritical steam. Third, the Benson boiler uses single-phase heat transmission, as opposed to conventional boiler, which use steam and water in distinct phases like liquid and vapor. Fourth, supercritical operation. By operating above the critical point of water, the Benson boiler avoids the liquid to vapor phase change. Fifth, rapid startup and response. The Benson boiler responds fast to fluctuation in steam demand. Lastly, compact design. Compared to traditional boiler, the Benson boiler typically has a more compact design due to its single phases, heat transfer mechanism, and simplified construction. So now let's move on to the advantage and disadvantage for Benson boiler. So advantage for Benson boiler is high efficiency, full load operation, compact design, improved safety, fuel type flexibility, reduced emissions, lower operating expenses, and suitable for high pressure application. And for the disadvantage of Benson boiler is complex design and construction, higher initial investment, stringent water quality, limited operating experience, less tolerant, regulatory compliance challenges, and lastly, limited fuel flexibility.
Greetings. My name is Muhammad Nasruddin, 0DKM 21F 2011. I'm going to continue the presentation best boiler between locomotive boiler and Benson boiler. We choosing the ideal boiler between the locomotive boiler and a Benson boiler is determined by a number of criteria including application specialist needs, operating concern, budgets limit, and regulatory requirement. But after long consideration and discussion, we decided to choose a Benson boiler as ideal boiler. We choose a Benson boiler as the ideal boiler because it is high efficiency. Benson boiler operate at supercritical pressure and temperature, providing higher thermal efficiency than locomotive boiler. The second one is environmental compliance. Benson boiler can be outfitted with innovative emission control technology to reduce environmental effect. If regulatory compliance with emission requirement is an important consideration, a Benson boiler may be a better fit for your needs. The third one is long-term cost saving. While Benson boiler may require a larger initial investment, their improved efficiency and lower fuel use can result in a long-term cost saving over the boiler lifespan. Fourth one, space availability. If space is not an issue and you value efficiency and modern technology, a Benson boiler's compact design and high pressure operation may be ideal. The last one is operational stability. Benson boiler provides steady and reliable operation, especially in application with consistent steam demand and load fluctuation that must be managed properly. The last one is conclusion. In conclusion, the Benson boiler represents the peak of engineering brilliance and invention in steam generation technology. Mark Benson invented this boiler design in the early 20th century, and it has transformed the efficiency, dependability, and safety of high-pressure steam production. The Benson boiler used the notion of supercritical steam generation to overcome the constraint of traditional boiler by working above the critical point of water. The use of Benson boiler involved carefully consideration of a few aspects. The Benson boiler is a triumph of engineering perfection, pushing the limit of steam generation technology to new heights. That's all from us. Thank you very much.